Okay, problem 2. Before doing the improper integration, you should first figure out what is x times log x to the power of p's integration. Right. Again, use u equals log x, which means it's integration 1 over u to the power of p du. Okay. So you see this kind of integration, there are only two cases, right? First, if p is 1, if p is 1, okay, and if p is not 1. If p is 1, which means it's the integration of 1 over u, right? The answer is log absolute value of u. Okay. If p is not 1, then the integration is integration of u to the power of negative p. So it should be u to the power of negative p plus 1. So it's 1 minus p over 1 minus p. Right? So when p isn't 1, it's this. Okay, which means, right, we can sub back u is log x, so it's log x 1 minus p. Right, it's log absolute value of log x if p is 1. Okay, so this is the first part. The second part, let's do the improper integration from 1 to 2, 1 over x log x to the power of p. You can see when x is 1, this log 1 is 0. It's not defined. So it should be limit t approaching 1 from positive side because it's from 1 to 2. Right. This integration. Okay. Then for this integration, because we already have the result, it is limit t is approaching 1 from positive side okay, it's piecewise function. It is this if p is not 1. Right, so it's this if p is not 1. Okay, it is log x if p is 1. Okay. So we just have to expand it. So the first one, when it is 2, right, when it is t, when p is not 1. Right. The second part, it's just log 2 minus log t. Okay. And for the first part, as you can see, when t is approaching positive 1 from the positive side, right, your log t is approaching 0 from the positive side. Okay, but you only know p is not 1. You don't know this 1 minus p is positive or negative, right? So this part we don't care because it's a fixed value. This part is a fixed value. So the only thing different is this 1 minus p is positive or negative. So let me write down here. So ln t to the power of 1 minus p is going to approach 0 if this thing is positive. Right? If this thing is positive, it's going to approach. If this thing is negative, as you can imagine, the denominator is approaching 0, right? So it's approaching positive infinity if this power is negative. Okay, which means, okay, so the first limit is going to be, okay, it's going to be, this part is going to be 0 if this happens, right? If 1 minus p is greater than 0. So if this part is 0, then the only part left is this, right? So it is this if, okay, 1 minus p is greater than 0, which means your p is smaller than 1, right? Okay, and it is, right, if this part is infinity, then overall, right, this part is negative, this part is also negative, right? So overall, it will be positive, so it will be negative infinity if p is greater than 1. Right, you can just, if this part is positive infinity, right, this is negative, so overall, this is positive infinity. This part I don't care, it's a fixed value. So it's negative infinity, which means it diverges, right? It's negative infinity, which means it diverges if p is greater than 1. Right. What about p equals 1? So when p equals 1, t is approaching positive infinity, right? Ln t is approaching 0 from the positive side, and ln t is approaching negative infinity, right? So the second part, it's also approaching negative here's a typo, right? Here's a positive infinity. So the second part is also approaching positive infinity. Okay, which means it diverges. It diverges. Okay. Okay, part B is very similar. So now it's from 2 to positive infinity. It's same integration. Right, so what we do is the same. It's limit p is approaching infinity. Right. This, which is a piecewise function, it is right ln x to the power of 1 minus p over 1 minus p from 2 to t, right? Or it is ln x from 2 to t. Right, here if it's p is not 1, here if p is 1. Okay, so the first part is ln t 1 minus p 1 minus p minus ln 2. Right, second part is ln t minus ln 2. So the first part, again, when t is approaching infinity, right, ln t is approaching infinity. So if this thing is positive, you can imagine if this thing is positive, then this thing is approaching positive infinity, right? And this is also positive. So the whole thing is approaching positive infinity. So it is positive infinity if, right, your power is greater than 0, which means your p is smaller than 1, right? And also when p is smaller than 1, right, you can see p is smaller than 1, this thing, when p is greater than 1. When p is greater than 1, this thing is negative, right? This thing is negative. So this to the power of negative something, it's approaching 0, right? It's approaching 0 over a constant. So if p is greater than 0, this thing is approaching 0. So this whole thing is approaching 0. So it's going to be just negative ln 2 over 1 minus p to the power of 1 minus p over 1 minus p. Okay. And when p equals 1, so we have to check here, when p equals 1, t is approaching infinity, then ln t is approaching infinity, right? Ln t is approaching infinity. There's no problem. So this thing is positive infinity if p equals 1. Okay. So positive infinity means it diverges